So in the interest of everyone's time, why don't we begin? And we will have a few minutes at the end for questions and answers too. Agenda slide. So on the next slide, I will give an introduction of the presenters for today's webinar and a very brief profile of the company, followed by the meat of today's discussion, which is AI, artificial intelligence, and some of the recent sound bites or trends in the industry and how you can get started. We will also discuss about two general use cases, AI in ITOps and AI in retail. We are also extremely excited to show you a demo on how you can use AI in retail, specifically image classification and attribution. We also hope to cover a couple of questions during our question and answers. So if you have any questions, please feel free to post in the forum and we will take a look at them at the end. All right, so let's begin. So my name is Amit Gandhi and I'm the co-founder and CTO for Parker Digital. And I also have Krishna Soni, one of my directors of engineering and science logic practice head for Parker. For the demonstration of the tool, we also have Ashutosh from Steamoid, one of our esteemed partners from AI vertical. Who we are. A very brief intro about the company. We are now into our 8th year of service, working with more than 80 enterprise clients across 10 different time zones. We have 300 plus cloud educated engineers with various skills, various specializations, many of them certified to work on multiple clouds. Some of our strategic partnerships include all of the leading cloud providers in Amazon, Azure, Google, as well as others on the application or tooling side in either Red Hat or Science Logic or Tidal, for example. We are featuring Science Logic and Steamoid in our webinar today. And we will also go in depth about a couple of interesting AI use cases using some of these fantastic products. Now, almost all of the engagements or the project work that we work on fall into 5 of these broad verticals. On the left-hand side, we have the product management area, where we engage with many of our customers to do a detailed discovery or assessment of their needs and come out with a product a roadmap that includes engineering backlog and MVP, marketing, and also the go-to-market strategy, to name a few milestones. On the user experience side, we have a lot of experience in conducting a detailed UX assessment to understand the gaps and come out with recommendations on improving them with respect to industry-leading benchmarks and also setting a few new ones. This, more often than not, is an afterthought on the engineering implementation side, but I think it's an extremely important aspect to drive your design and user experience. And we have always recommended our customers to look at user experience from the get-go. The next one is on the product development side and pretty much our bread and butter in everything that we work on. This includes working on greenfield applications, modernizing or refactoring legacy applications, or migrating some of those on-prem workloads onto the cloud. DevOps is a critical component of this, where we have automated provisioning of environments and also the whole release deployment pipelines using some of the industry standard templates and frameworks. Now, all of our recommendations have been on Agile, and we have always encouraged our customers to do as much automated testing as they can. So engineering and development followed by automation testing and also doing some of the industry leading DevOps not only enables us, but the customers to go much faster and continuously and constantly increase the velocity while ensuring that all of the processes are being met. Once an application has been moved to production, we do have 24/7 teams to sustain and monitor these workloads. We have used standardized tools and platforms in our operations teams and have around the clock operations for network, operating systems, infrastructure, as well as application support. We have recently added 24/7 SOC capability, extending security and support for many of our critical customers. Finally, analytics and for data, our teams have advanced capabilities in data analytics, both for product and end users. Be it Google Analytics or Adobe to get user insights or use Azure Data Factory or Snowflake for data lakes and real-time data engineering. We do have expertise on solving some of the pretty complex data use cases, and we will maybe have another webinar in the near future to discuss our capabilities on the data side and take one or two use cases in depth. Now, let's get into the meat of today's agenda, which is integrating AI in applications and what is AI all about. I believe everyone will agree that the impact and promise of AI is profound, but it's not all happening at once. And I think we're only at the beginning of its potential. AI is found everywhere in our digital lives. Artificial intelligence is transforming the way we live, work, and do business. The adoption of AI is now resulting in a world which is much more smarter and innovative. The incredible speed with which AI is entering every sector, every industry is compelling many companies to become an AI company. IDC recently predicted that worldwide spending on cognitive and AI would reach almost 78 billion by the end of this year. Now, some of the leading industries where AI is already making an impact is transportation, education, healthcare, retail, and e-commerce, to name a few. Now, what are some of the AI use cases which are already in the industry, right? Siri, Alexa, self-driving cars, conversation chatbots, and even Netflix recommendations are all examples of artificial intelligence in today's world. Many corporations like Google, Facebook are working on their own complex AI technologies, solving different types of machine learning problems and just developing new algorithms. Current uses of artificial intelligence are so diverse that it becomes a bit difficult to define where or which sector they belong to. It's just omnipresent. Now, I'll not go into detail on each of these AI use cases, and perhaps you have your own favorite AI use case, but I think all of us can agree that AI is everywhere, and all of us at least need to understand how can I make use of AI. Talking about AI adoption, in our experience, AI can broadly be categorized into two: AI in the IT landscape, be it infrastructure or IT operations to help improve the bottom line, or AI on the business side, helping solve some of the ways to increase a top line. Over the next few minutes, we will take an in-depth look at both of these use cases. For IT and IT ops, we will look at how Science Logic is transforming the AI ops landscape with its SL1 platform. And Krishna from the next slide will go in detail about the platform and his experience from an engineering and a usage standpoint. After that, we will have Ashutosh and team go over a common use case in retail and how some of the leading e-commerce companies have been using their platform for solving some of the complex business problems and leveraging the power of AI for sales conversions or using it for their upsell and cross-sell strategies. With that, let me invite Krishna to talk about science logic next. Krishna?
Thanks, Amit. Hey everyone, I'm gonna talk about how Science Logic's SL1 platform helping businesses automating their ITOps journey, right? Science Logic basically kind of a monitoring tool, right? Which basically monitors your application servers, storage, virtual machines, and the infrastructure, right? With SL1, you get insight of your infrastructure, right, and services health, how these services are performing, and if there is a problem, right, it helps identifying the problem at a stage, right, where you can basically perform actions, right, to resolve the issues before they impact the business or the user, right? So with that said, I'll go basically into a bit more detail, right, and explain science logic, how it works, right? So Amit, if you can go to the next one. Right. So IDOps is not all about basically collecting the data, right? It's about adding the context and finding the data, right, which basically gonna impact your operations and then act upon it. So how Science Logic does that for the businesses, we're gonna see that in the next slide. So the basically the data is the foundation, right, of any AI ops. So IDOps, and it's not just about collecting the data, as I said a second ago, right? It's about adding the right context and basically get insights from the data, which enables ID to understand the potential impact, right? And so that the IT team can focus on the most important things for the business, right? But as I said, data is the foundation, right? And just raw data would not be helpful, right? So that's where we have the analytics, right? Where we perform some algorithms and operations on this data to add the context and derive the insights, right? And then SL also applies ML to basically find the patterns or behavior, right? Correlation in the data and the health. And also it can advise the next steps. So that is where analytics comes into the picture. And finally, the automation, right? So intelligent automation helps solve the problem faster, right? So something which is done manually, right, would take some time. There would be handoffs between multiple teams to restore a service or fix a problem, right? But if we do it automatically, right, then it would save us a lot of time and probably things would be done faster. And that's where Science Logic as a tool integrates with the ITSM tools, right? So you can automate your workflow automation and the incident management. Amit, can you move to the next one, please? So here, basically, you get an insight in the SL1's kind of high-level architecture, or how does it work, right? So if you check the left-hand side, right, on this diagram, you see a lot of data coming from basically various data streams, devices, applications, and this is all raw data, right, which goes into the Science Logic platform, SL1 platform. And then if you see one of these sections, right, the first sections in the middle diagram, right? So you see that the data which just gets added into the platform, it gives you insight on your services or events, alerts, right? How is basically overall infrastructure health is, right? But again, it's just a raw data. It gives you some insights, right? It's not intelligent data, right? Which basically helps you derive something meaningful. But again, it gives you enough insight on the service health, right? But then SL as a platform, right, adds a lot of context, right, because it has a lot of historical data, all right. It applies algorithms, and then it basically does anomaly detection, right, where it performs the comparison with the historical data available, right, and it finds the anomaly, and then it informs basically the IT, right. So you get the insight, now more meaningful insight, as well as the final step, which Science Logic would perform, right? It would integrate with your ITSM, and then it would kind of automate the entire incident management, enrichment, and then finally performing some steps or remediation, right, to fix the issue quickly. And then, as I basically just mentioned it, right, on the right hand side, you can see how it integrates, how SL1 platform integrates with some of the other ITSM tools, right? So there are APIs or data streams, right, which helps basically connect the IDSM with SL1, right? So it can kind of create the incidents, add more information, and also it can start acting upon it, right? So that's how Science Logic SL1 platform works. Amit, if you can go to the next one. Yeah. So now we're going to talk about machine learning, right? So how machine learning helps identifying or detecting the anomalies, right? Amit, can you go to the next one? Yeah. So again, right, it's not just about seeing the data or getting the data, right, which is pretty raw and probably not as useful, right, as it should be. So SL1 basically again organize the data, right? It normalize the data, gather the data from multiple devices, multiple applications. Again, perform some operations, right? Adding the context, and then it starts basically. It can also act upon it. Amit, can you go to the next one, please? Yeah. So, like we're gonna discuss about anomaly detection, right? Anomaly detection in a generic way, right? It's all about understanding if this is the expected value, right, or the expected data, or have we seen this before, right? This pattern or this behavior. So it's all about identifying the behavior or pattern, right, and then raising the alarm. So how SL1 does that, we're going to discuss that in the next few slides. So again, as I explained, right, anomaly detection is just about finding the rare items or events or something which does not happen very usually, right? And how SL1 does it, it has algorithms, right, which basically runs on the collected data, and then it learns, right, that what is the normal performance for this particular device or application, right? And then it also, over the period of time, right, when it has enough data and the data which is already available, right, and the data which is coming, so kind of it would be compared, and then it would find the strange behavior, and it can also adapt the new behavior in kind of real time. Amit, can I request you to move to the next one, please? Yeah. So, as I was explaining, right, how SL1 works, so it basically has data available of multiple devices, infrastructures, applications, storage servers, right? And then it keeps collecting the new data, right? And the ML-based model, right, which keeps comparing this data and find the anomalies, right? So it keeps doing the analysis, and that, of course, the new data would be again would be fed into the models, right? So that it can improve itself when it's performing some of these analysis, right? So ultimately, the aim is to identify an anomaly, right? Whether the value which is coming right now, whether it's expected based on the data which is available with SL1 already, right? So it performs and then it finds if there is a strange pattern or a behavior, right? So then the identification is done, right? And the problem is identified. And then again, it kicks the workflow automation as I was explaining earlier. Amit, if you can go to the next one, please. So here is an example, right? So it's a service, right? And the blue shade, right? The background, blue background, is basically the expected or the acceptable range of the data, or rather, I should say, values. And then the green lines, right? It basically represents the actual data, which is the current data incoming, right? Blue is basically kind of defined expected range depending on the historical data available. And now you see these red dots, right? So these are the anomalies which are being detected by SL1, right? So now it knows that something strange has happened, which has not happened earlier, right? Depending on based on the comparison, which is doing kind of real time. So now it identifies these anomalies, right? The red dots in this diagram. And then it raises the alarm and it does kick in the workflow automation, right? Yeah. So so this slide kind of talk about the expectation, right, from this behavioral correlation, which basically is done by the SL1 engine. The events or the anomalies which has been identified, right, based on the comparison. The idea is to reduce noise and accelerate the RCA, right, and it can also perform some of these app operations or remedies, right, which helps you reduce the issues which are occurring. So yeah, these are the some of the key takeaways from basically the slides which we have just discussed. So Science Logic gives you an insight on the data which is being collected real time, and also it adds context to it so that IT can act on it. The ML based machine learning based model, right? It does the heavy lifting, right? Running the algorithm, performing a comparison with the existing data available, and then identifying the anomalies. And also it keeps adding, right, the data, the incoming data to the model so that it can improvise itself. And overall, the expectation is that ML drives the service health. So yeah, that's how Science Logic SL1 platform works and helps the businesses in this way. So Amit, I think I'm done.
Okay. All right.
I'll turn it back to you.
Thank you,
Thank you.
Krishna. So we do have one or two questions for you, Krishna, but we'll probably take it at the end, right? We do have
Sure.
the much awaited demo on the retail side. So Ashutosh, you have a few extra minutes if you wanted to go in depth on the retail demo and use cases. So let me turn it over to you and I will move the slides. Yeah.
Okay, sure. So what I'll do is quickly I'll take 2 or 3 minutes to introduce the product in just a couple of slides. Then we will directly get into the demo. And then I will come to the architecture of how we have built this product in case we have time. And then we'll come to the Q&A. So this product, which we call as AI Studio, is basically, you can say it's a low code or no code AI solution to be integrated into your workflows. And this is an end-to-end solution which has about 500 plus models handling about 20 plus problem statements in the domain of fashion retail. Now, to give you everyone an idea, where is this like platform used by, or who are the users of this platform? Are primarily four buckets. There are data science managers, that is data science and analysts. There are business analysts because AI models are easier and faster to be implemented than ETL processes. Then data scientists, like this is the core segment. What happens in data scientists segment is that what happens in while you are a data scientist, while you work on a lot of problem statement, a lot of your work goes on data preparation and ensuring there's good quality data, and then data benchmarking and detecting or comparing data. So this takes up a lot of time rather than the core data science work. So there we have this product which helps you with advanced data quality check, bias detection, and its one-click deployment along with feedback API. And IT service providers who work on various customers or when they have like 10 customers in the same industry, they solve somewhat similar problem, but we have abstracted the learnings from every problem so that when someone works with a similar customer, you have a base model and you just need to fine tune the model. And all of this model has complete data protection, and it is melted in a data storage modeling. So the data of every client is separate in a cloud of their own client, and there is no data privacy infringement across any models, across any platforms. Okay, next slide. So now my colleague Kingshuk, who heads engineering, who is also part of instrumental building this product, will get into a demo. But I'll just give you a 2-line brief description of what we have done using AI for a couple of our customers. So in the first case, what we did is that we have used object detection to train ML models. And these, by using object detection, we are able to generate about 28 to 30 attributes for every garment or a fashion object. So by this, what happens is that since the machine is able to predict 28 to 30 attributes for every photo, you have attributes and they can be used to enhance your search discoverability on your website, on any e-commerce website or your brand.com website. Now, second is that how does this link to the second part of it? That since you have data, we have automated this AI will help you generate product description. Since you already have the tags or you have the details which are determined by AI machine using the models and generate attributes for each and every dress, you are able to generate product description. Now, in a real world, how will this process happen is that this process will go in a manual way where a content team of around 200, 300 people will sit and see physically, generate attributes by writing it down and then writing description based on a creative stage. So this is where the power of AI comes in, where you automate the entire workflow using object detection and using text detection. And as just to give you an example, what we did using this, in the attribute detection in one of our customer using these base models, we had a real world accuracy between 85 to 88%. And using AI, we are able to generate descriptions for more than 1 million products and do a QC on those in about 4 or 5 days. So you would ask that why QC? Because no AI or machine learning system is 100% accurate. While they generate things, there is always a human in the loop which sees whether what generated is okay or not. So this is it. So now I'll hand over to my colleague Kingshuk, who will just take a use case in this, how this whole product demo. So seeing the product would be okay.
Thanks, Ashutosh. I'll go on and share my screen now. I hope you guys can see the screen. So this is the login page of our tool, which we call AI Studio. As you can see on the left, we are showing different problems which it can solve. Let me log in and show you from the inside. So these are different projects. Let me start with how we can create a project and how many types of project we can create. Mostly this tool solves a lot of problems on the image recognition side. So as you can see, we are solving image tagging, which is a classification problem. Image segmentation, which is something similar to background removal or foreground detection, those sort of problems. Then we have like text classification, which I think it can take text data and then predict certain tags based on text data. And then we have other problems like collage generation, in which it can take different photos, put them together in a more aesthetic way. and object detection, in which it can detect different objects within an image. So going back to some demo projects that we can show, let me show you a project which with a model which we have recently trained to get a sense of how it works and what it can do. So in this tool, we have two major entities or objects which we say. So one is data, because data is the most important thing. So we have dataset versioning implemented in this. So in this, we can actually go and we can open and view data. To add data, it's very easy. We can go back and we can just create a new data set that will basically allow us to input data. So these are already pre-created data sets which can be visualized, and based on the tags, we can filter them. We can see what kind of data is there, and then we can make sense of the data. Now, given these data sets are there, now we can go to the training problem, which is how do we create a model? So for that reason, we can go to the models tab and choose create new model. Now in this, we will need to choose what data we want to train on. So maybe if we can select this, which has a good number of images. And also because machine learning models need to know how will we know that our model which we have trained is good enough for real world use cases. So we need to provide a validation data set. So in the next step, it will ask a validation data set. Now, since training is a time-taking process, I will simply show the model which we have previously trained. So suppose we do this process, it takes usually about a half an hour to 1 hour per model. And once it has built a model, it will automatically deploy the model. And the model deployment URL can come here based on deployment, and it will generate unique IDs. The model deployment cycle and all that can be controlled from here. So one more important aspect of this tool is that we can do analysis of the data. Like if I've got a model which is giving me 97% accuracy, can we do better? So in this case, it presents with the beginner level statistics. So if you don't know machine learning so much, so then you can actually see that, okay, what are the label wise accuracy? So in this case, for example, embellished is giving me 98% accuracy, which is good. So, but it can also show, okay, what are the things which might be failing? So it can show that, okay, these, in this case, 3 images are being classified from embroidered to embellished. So this gives a insight, okay, what are the classes being confused, and it will allow you to take appropriate action. And it can also allow you to visualize, okay, what is the typical confidence range in which these labels are getting predicted. So this is what Violent plot does. And one more plot which we give, and it's a good idea to look at this plot is, okay, are the features which are being generated, are they being separated in a higher dimensional space correctly? So as you can see, all the 3 classes that we have are being separated in a good way by the model, which means it's a good model to use. It might perform well on the real world data. So this was the classification problem. Let me quickly also go to one more problem, which is the detection. So this was a detection model. Detection model basically is one where we are given bounding boxes for different objects in the image. So let me visualize one of the data sets. So for example, in this case, if you want to look at long top wear, so in this case, we can see that there is a model. There are many models which are wearing long tops, tops which have a hemline which is quite low. So going back to training, like or looking at the kind of model it generates. So it has generated a model. Some models have failed because maybe the data set was not good enough. And going into the reports, we can see that, okay, it is giving a 50% accuracy. So since this is a detection model, the accuracies are not of that level. because this is also good in practice, but it's a way of representation. Like industry accuracy, 50% means that it might also be including the area of the detected region. So in this case, also we can go for some sort of analysis, and it can do basic analysis like, okay, what are the accuracies on a per label or per bounding box basis. So this is the rough demo. I think, yeah. Thanks. I think I'm done with the demo.
And is there any way, Kinshuk, to also look at any of the models or any of the recommendations which came out of the model?
Sorry, can you repeat?
So I was just saying, Kinshuk, is it also possible to look at any of the models here and also any of the suggestions or recommendations which come automatically from the product?
So this one is not, these are specifically projects. I think we will need to look at a different part of the product to actually come up with recommendations.
Okay, sure. All right.
Okay.
Thank you, Kinshuk. So
Thanks.
Okay.
let me begin to share my screen again, and I request Ashutosh to discuss about the product in some more detail. So just give me 1 second, Ashutosh.
Okay. Okay, so I'll just quickly, in about 2 to 3 minutes, explain the architecture of the product which you're seeing. So basically, this is like a low code or no code AI solution for fashion retail. Now, if you see broadly, what does this have is that it has a fashion intelligence layer or a domain layer which is built into any AI machine or any of these kind of models. So here it is like a universal fashion taxonomy, that is the standardization labeling along with the rule engine which is built in. And if it is healthcare, the rule engine changes, but the base models change, remain same at the algorithm level. So as like with every AI application, you need to have a domain layer, or you can call as a domain intelligence layer, which works across these models. Now, for fashion retail, especially the type of problem statements we have classified, or there are about 500 plus built-in models, which are across different categories. That is image classifier, image segmentation, object detection, multi-level classification, image this one, and text classification. Now, to just give an overview of how is this different from any of the existing model, when it comes to any B2B application, there are general purpose AI models which are trained over a domain-based problem using a training and data set and label data set for the particular domain. That is how this pre-built models library comes in for every domain. So in this case, we have this library for about fashion, and we have about 500 plus models, and every monthly we add around 500 plus models. So as and when we develop any custom purpose AI models for any particular application, we built it into this. Now, how does this help customers to use this? Is that since these are pre-built models, you don't need to do the entire workflow of data preparation, building the base models, training the base models, using sourcing the label data set, and then deploying it and then enhancing it, because there's already a base model. You just need to do some customization based on your application. And for every company or every application, there will always be some customization on the pre-built model, because it's your company or your problem statement, and there is an approach to solve that problem statement. And this is where the data preparation, model training, model deployment, and data visualization or data analytics and real world application and the output of it is being deployed in the product to show you the results. So this is the entire way the architecture is structured. And more, so this is what we call as low code or no code, because since you already have a model, you don't need to do, you just need to use your data to plug and play, and you don't need to do the entire workflow in terms of going through the entire thing, which saves you at least between 3 to 4 months of time on a particular data science problem. And you can directly come to solve problem for your own company or your own industry in your structure. Okay, next slide. And this is how the data flows is that you have a training data set created. We already have a lot of training data set created. In a normal case, for a problem statement, you would have to go around in the market buying data sets, etc. We have already done that part of creating data sets and having labeled data sets. We already have base models. We have insights. You can deploy it and see how to further fine tune it, and again put it into production and see the inferencing. And it is an easy method to see where it is going wrong and check and doing an annotation again for your data set, so that you have a better trained data set or a better output data set, which can again be flown into the same CI/CD pipeline, so that it is like a continuous AI ops or ML ops setting for you for your problem. Next slide. And what type? So while we have, so why do people use this product? Is that because as a data scientist or as any company in AI, you would like to choose a problem you want to solve and prepare based on your own data, because the definition of a problem differs from a company to company within a domain also, or even a business unit to business unit. Only thing it gives you a set of pre-built accelerators to help you reach your results and iterate and deploy and learn very quickly, as compared to doing the entire process from ground up. So it is about 70-75% of the base thing you get it on you, and you just have to customize it and use more of your data science algorithm or data science maths on it, rather than doing the entire IT ops or ML ops part of it, since this is already taken care. So this is where people find this product to be used, and this is why this is the main USP of the product. You can see. Yeah. Good. So I'm done.
Okay. Thank you, Ashutosh and Kinshuk, for the wonderful demonstration. I think it does give plenty of ideas to the attendees on how AI Studio can be leveraged for their own problem statement. So thank you very much for that.
Thank you.
Now let's get into questions and answers. And I do have a couple of them for Krishna, and I also have a couple for you, Ashutosh. So
Sure.
let's begin one with AI for ITOps. And one of the questions is, how much of human involvement is required in tools like these to automate IT operations? Krishna?
Yes, Amit. Basically something like Science Logic, right, which is easy to set up, right? So I'll just go into a quick detail, right, how SL can be set up, right, to monitor the devices or applications and then automate the workflow. So you can install SL1 in your own premise, right? And then you can open up the devices, right? So that SL1 can discover them, and then it can start collecting the data, right? Another option is you can have it installed here on your own cloud, right, as a customer. And then the third option is Science Logic does it for you, right? So they manage the SL1 instance, and then they do the initial setup, they discover the devices, and this enables the monitoring, right? So now once the tool is set up, right, it takes very minimal effort, right, initially, just to make sure that all the devices are basically providing or sharing the data, right? Because Science Logic does the both agent-based and agent-less monitoring, right? So it collects the data, and it basically starts giving you insight. So the answer would be the human effort would be very, very minimal, right, to set it up once and then add the devices or discover the devices.
Okay. Thank you, Krishna. So let me pick one for Ashutosh. Now, what kind of data processing can AI Studio support? Is it only specific to retail domain?
Data processing can be supported for any domain. At present, we have built in the intelligence layer and models for only retail domain. We will add more domains going forward. As of now, the intelligence layer and the base models are for retail domain. Data processing can be supported for any domain.
Okay. And I think one of the other related questions, Ashutosh, is this also for pharma industries? And if you have any example or two.
At present, we haven't done anything for pharma, so we don't have an example there. But it can be custom built for pharma, but we have to add more problem statements and then data sets and do the process.
Okay. And then I have one more for IT ops. So, Krishna, question for you. How can we automate or accelerate RCA, root cause analysis? This seems to be a big issue for infrastructure.
Yes.
So your ideas on
And
this?
yeah, so it's not very easy to explain as well as understand, right, without giving a kind of a demo. But yeah, so what basically you need to think of the infrastructure, right, the complexity of the infrastructure. If I give an example, right, a distributed application, right? It can have multiple application servers, storage servers sitting behind a load balancer, and then there is a static storage or database, web servers, right? So it's a complex infrastructure, right, for basically hosting a distributed application. So now what happens is Science Logic basically kind of creates a map, right, or maintains a map of how these different application servers or storage servers, web servers, load balancers are connecting to each other, right? So it has a map, right? So there is a utility in the platform, right, which helps you coming up with this map, right, where different devices or application servers are connected to each other, right? And then the diagnostic data, right, which basically is feed as part of the data collection into the SL1. It basically try to find the issue, right? So if there is a problem, let's say at the storage end, right, it tries to identify that problem, and then maybe it does not always detect the exact problem, right? But it basically helps you isolate the area, right, where the problem can be, and then it can provide you again enough data within that isolated area, right, which helps you to find the root cause quicker, right? Some of the common issues or the common health checks are in place, right? So they can detect the problem based on the data available, right? Historical data available. There are some problems, right, which cannot be detected so easily, but SL1 at least helps you isolate the problem area, right? And you can at least get enough insight, right, with the data basically it collects to identify the root cause.
Wonderful. All right, let me see if there are any other questions at this point. Yeah, and I do have one more for Ashutosh. Can we give data in CSV form to create a
Yeah,
data
yeah,
set and do some
yes,
validation?
yes.
Wonderful. Okay. Okay. All right. So I will encourage any of you or all of you, if you have any follow-up questions, please get in touch, and I will include a couple of links at the end of the webinar. The only other thing is to thank all of you for attending this. Hopefully the demo was interesting. The piece about science logic and AI in IT ops was interesting. But more importantly, this has given you plenty of ideas on how AI can be leveraged by your industry, how you can start looking at AI as your to complement some of the work that you've been doing. AI is not a monster. AI is here to stay. Sooner we adopt AI, sooner we get comfortable with AI. I think it's going to help everyone. The only other thing to add is we were having our series of webinars on cloud migration and modernization. We have completed 3 webinars on it, and the next webinar will be scheduled pretty soon about security and operations readiness. But based upon some of the feedback, some of the industry trends that we've been seeing, we felt it was important to do a one-off webinar on AI, and we will schedule another webinar on AI or some of the upcoming trends. But if you have any ideas, if you wanted to see anything in any more detail, please get in touch with us. Yeah. And this brings us to the end of the webinar. We have completed about 8 or 9 minutes early. So happy to give you back 8 or 9 minutes into your busy schedules. And once again,